Consider a dog that has a chromosome with 3 linked loci on it. These loci are for fur color, eye color, and tail length. Black fur is dominant to red fur, brown eyes are dominant to blue eyes, and long tails are dominant to short tails. A female dog with black fur, blue eyes, and a long tail mates with a male dog that has red fur, brown eyes, and a short tail. The coefficient of coincidence value is 0.64. This genetic map shows that there is a distance of 16 centimorgans between fur color and eye color, and 9 centimorgans between eye color and tail length. If we look back at the parents, they're going to have an offspring that is heterozygous and has black fur, brown eyes, and a long tail. This child is going to mate with a homozygous recessive dog. Together, these dogs are going to produce 8 different offspring. One offspring is going to have black fur, blue eyes, and a long tail. Another is going to have red fur, brown eyes, and a short tail. Another is going to have black fur, brown eyes, and a short tail. Another is red fur, blue eyes, and a long tail. Another is black fur, blue eyes, and a short tail. And one more is red fur, brown eyes, and a long tail. And the last 2 are black fur, brown eyes, long tail, and red fur, blue eyes, and a short tail. Now, if we look specifically at a gamete that got its genotype because of a double crossover event, we can see that the only way for it to have red fur, blue eyes, and a short tail is to have a crossover event here at R1 and a crossover event at R2. If you look at the probability calculation, we're going to see that we're multiplying R1 times R2 times the coefficient of coincidence value and multiplying by 1/2 to get a single gamete from a double crossover. Now if we look at a gamete that got its genotype because of a single crossover event, we can see that the only way for this gamete to have black fur, brown eyes, and a short tail is to have a single crossover event at R1. The probability of this happening is 1/2 times the R1 value minus the double crossover event, and you're going to get 1/2 times 0.16 minus 0.004608. The table shown here shows what the predicted probability for all 8 gametes are. The gametes produced from a double crossover both had a probability of 0.004608. The gametes produced from a single crossover in R1 both had a probability of 0.077696. The gametes produced from a single crossover in R2 both had a probability of 0.042696. And the gametes that were produced when no crossover occurred both have a probability of 0.875.